Good morning, students. Once again I welcome you to my video lectures on signals and systems. And in the last class I explained what is one-sided Z transform or unilateral Z transform. Today I will continue with one-sided Z transform. Now heading. Now if you could remember the properties we studied. When we studied double-sided Z transform, we went through many properties of Z transform. Could you remember? Linearity property, multiplication by an exponential sequence, differentiation in Z domain, then differentiation, then time shift property, time reversal property. These were the properties. Now, if you come to these properties, now the question is, what about properties in the case of unilateral or one-sided Z transform? So, among properties, almost all properties are same as double-sided, except the two. The two properties that differ. Number one, time shift property. Time shift property. So, time shift property of two-sided Z transform is different from one-sided Z transform. Time shift property. Another property that is irrelevant is time reversal. Time reversal is not applicable. The reason is one-sided Z transform means n is greater than 0. So, what about time reversal? Time reversal means negative values of n. Therefore, this is irrelevant. Time reversal is irrelevant. So, we have to consider time shift property. Now, time shift property. What about time shift property? Today, now, I will derive an expression for the time shift property. Now, if you remember, during the two-sided Z transform, what is the Z transform of x of n minus n naught? X of n minus n naught in the case of two-sided or double-sided Z transform is z to the power of minus n naught x of z, where x of z is Z transform of x of n. So, this is in the case of the two-sided or double-sided Z transform. Now, what about z of x of n minus n naught? X of n minus n naught in the case of unilateral Z transform. In the case of unilateral Z transform, it is slightly different from this. Today now, I will go through this property. Now, what is Z transform of? What is unilateral Z transform of x of n minus m? X of n minus m. I will use m. X of n minus m, where m is positive, where m is greater than 0, m is positive, and in deriving this, I will assume that the Z transform of x of n. So, unilateral Z transform of x of n is equal to x of z, where x of z is equal to summation n equal to 0 to infinity x of n z to the power of minus n. This is x of z. Now, we shall derive what is Z transform of x of n minus m. Now, first, as usual, start. So, what is Z transform of x of n minus m is equal to summation n equal to 0 to infinity x of n minus m z to the power of minus n. Now, let us use change of variables. Now, I will call n minus m as k. I will call n minus m as k. Now we have to replace n minus m by k. So x of k. Then z to the power of minus of n. What is n? N is k plus m. N is k plus m. N is k plus m. What about limits? Now when n equal to 0, what about k? K is equal to minus m. When n is equal to infinity, if you substitute here, k is again same, infinity. Therefore, here we have to change the summation limits as n equal to 0. So k equal to minus m. Then here it is k equal to infinity. So having changed over to another variable k by replacing n minus m is equal to k. Now I will split this summation. I will split this summation as now minus m. For example, m may be 1, m may be 2, m may be 3. So I will split this summation as summation k equal to minus m to k equal to minus 1. K equal to minus 1. Then x of k. Then you write z to the power of minus k and z to the power of minus m. Take out outside. Z to the power of minus m. So this is what the splitting. Now next. So from minus m to minus 1, the next is, it has to continue with 0 because after minus 1 it is 0. Therefore, k equal to 0 is equal to k equal to infinity, x of k, and here z to the power of minus m, z to the power of minus k. Now what is this? So this is same as here, the letters are different. Here it is n, here it is k. But the form remains same. Therefore, the whole of this is nothing but x of z. We have called this as x of z. Therefore, x of z, z to the power of minus m. Z to the power of minus m, x of z. And the other term is z to the power of minus m summation k equal to minus m to k equal to minus 1 x of k z to the power of minus k. This is what is called as the derived expression for z transform of time shift property. This is time shift property. That is right shift property under z transform. Now I will take specific values for m. I will take m is equal to 1, m equal to 2, and I will write the expression. You can remember it. So this is a rather complicated to remember. So instead of that, we shall simplify this. So we shall have specific values for m, and we shall write expression for z transform of time shift property under z transform, one-sided z transform. Now I will take m equal to 1. If you take m equal to 1, what is z transform of x of n minus 1? Now m is 1, therefore first one. So as m is 1, the one and only term I have to write under this. Therefore z to the power of minus 1, z to the power of m is 1, z to the power of minus 1, and here k takes value minus 1. Therefore x of So this is x, rather small x, x of minus 1, x of minus 1, then z to the power of minus 1, because minus k means minus k. So my z to the power of minus k, and k takes value minus 1, therefore z to the power of minus 1 plus z to the power of m is 1, z to the power of minus 1 x of z. Therefore z to the power of minus 1 x of minus 1 z to the power of 1 plus z to the power of minus 1 x of z equals z to the power of minus 1, z to the power of 1 cancels, therefore z to the power of 0, therefore x of minus 1 plus z to the power of minus 1 x of z. So students are very well supposed to very well remember this. So what is z transform of x of n minus 1? X of n minus 1 is x of minus 1 plus z to the power of minus 1 x of z. Now I will take m is equal to 2. I will take m equal to 2 and I will write the expression. Now take m equal to 2. Now take m equal to 2, x of n minus 2 equal to, first this term remains as it is, z to the power of minus 2 x of z plus, now there are going to be two terms from minus m to minus 1 means, so as m is 2, so minus 1, so m is 2, minus 1, minus 2. First I will take minus 2. If you take m equal to minus 2, if you take m equal to minus 2, then z square x of minus 2 z to the power of minus 2. This is one term. Another term is, after this minus 2, m equal to minus 1. Z of m is 2, z minus 2 x of, now it is minus 1, x of minus 1 z to the power of minus 1 equal to z to the power of minus 2 x of z plus, now here z to the power of minus 2 x of minus 2 z of minus 2. So this one cancels. Therefore we are left with x of minus 2 plus z to the power of minus 2 z to the power of 1, that is z to the power of minus 1 x of minus 1. In the same manner, one can write what is z transform of x of n minus 3, n minus 4, etc. Now, as m takes more and more higher values, more and more terms get added up. So this is a very important property. Now, in this class, I went through the time shift property of z transform, that is unilateral z transform. Thank you.